Hi, I am Nirav. I am from California State University, Sacramento. In this video, I am going to explain part of a project on H264 that I am doing under Dr. Jing Pang. Video codecs are using motion estimation techniques to compress a video. Let me explain how this motion estimation works. This is a frame of a video and this is the next frame of the same video. All these frames are in CIF format. 3. In motion estimation, each frame is divided into several macro blocks and only information about that macro block with respect to previous frame is sent. So see how advantage of macro block is compared to sending pixels of entire frame. See here, if I want to send a frame in form of pixels, then I need to send information about 101,376 pixels. Now in place of that, if I am sending information about location of a macro block, then there are only 1,584 macro blocks. So in place of sending this many pixels, I am just sending information about these macro blocks. Motion estimation is a very complicated task. In that, each macro block is compared at several places in reference frame to find a good match. Early video codecs like H261 and MPEG-2 were using techniques like new 3-step search and diamond search to find a good match. Now I am going to run a simulation that does comparison between adaptive root pattern search and diamond search. In this top file, I am passing current frame as well as reference frame in input to both, that is adaptive root pattern search and diamond search. As an output of these two functions, I am getting motion vector of each macro block as well as average computational cost. Notice that it already has completed calculations for first set of current frame and reference frame, where computation for diamond search is 29.34 while computation in case of ARPS is just 12.35. After that, with help of motion vectors, compensated image is generated and peak signal to noise ratio in both cases is calculated. Notice that here peak signal to noise ratio of ARPS is 42.69. Oh, the simulation has completed. So let me show here the plot. Here I am just the values received in this simulation are just plotted in terms of graph in these two figures. Notice that this figure is showing cost comparison between diamond search and adaptive root pattern search. Note that the overall cost in case of diamond search is much higher than overall cost in case of adaptive root pattern search. On the other hand, if you see peak signal to noise ratio, then peak signal to noise ratio of adaptive root pattern search is much higher than the diagonal search. I ran the simulation for multiple frames and see that in case of adaptive root pattern search, the overall cost in all comparisons is much less than the cost of diamond search, and even that I am getting very good peak signal to noise ratio compared to diamond search. It concludes that the new adaptive root pattern search algorithm is more efficient compared to conventional motion estimation techniques.